Now let's take a look at wake turbulence or wingtip vortices. Now, wingtip vortices occur because anytime an airplane is flying, there's high pressure underneath the wing, low pressure area on top of the wing, so the air from underneath the wing tries to make its way around the wingtip and join that low pressure area on top of the wing. Well, the problem is by the time these molecules make their way around the wingtip, the wing is gone. It isn't there anymore. So what you really get is these wake turbulence or wingtip vortices that come after the aircraft. Anytime an aircraft is producing lift, you'll have these wingtip vortices like so, and they occur worse when the airplane is at high angles of attack at the wingtips. Now, would you be at high angles of attack at the wingtips when the airplane is heavy or light? Well, when the airplane's heavy, you'd have the biggest angle of attack. How about when the gear and flaps up or down? Well, when the flaps are down, the airplane pitches down just a little bit, and the angle of attack at the wingtips is less. But when you remove the flaps, reduce the flaps, the airplane pitches up, and the angle of attack at the wingtips is higher. And when the airplane is slow, the angle of attack at the wingtips is greatest. So when do you have the greatest wake turbulence behind an airplane? Well, when the airplane is heavy, clean, and slow. Now, these vortices are a danger to you when you're flying in a little airplane and you're following a bigger airplane because these can actually roll you upside down. Now, if you're flying at 2,000 feet and you get caught in wake turbulence and do an inadvertent roll, it scares the daylights out of you. But at 50 feet above ground level, it can ruin your whole doggone day. So you see this Boeing 747 equipped with smoke generators shows you how these vortices affect you as you're flying along in a little airplane following this airplane, and they can ruin your whole doggone day when you're in short final if you don't know how to behave around wingtip vortices. So the important thing to know is to know how these vortices work. First of all, they tend to sink behind the airplane. So if you want to avoid the vortices of a big airplane, you would want to fly above the altitude of the aircraft that's generating the wake turbulence. So they tend to sink down below behind the airplane. Also, you should need to know that when you get near the ground, they spread apart. So here you have the airplane generating lift. Anytime that there's lift on the wings, you have the wake turbulence. They sink behind the aircraft and they spread apart. And the wind condition that requires maximum caution when you're avoiding wake turbulence is a light quartering tailwind. Now here's why. Let's assume that these vortices drift apart, as we said earlier, at about a rate of, we'll say, 5 knots. And let's assume you have a 5-knot quartering tailwind. Well, you can see what would happen. This upwind vortex could be held right over the runway. The downwind vortex would be blown away, and that's no problem. So, and you have a light quartering tailwind, the upwind vortex could be right over the runway, and that could be your most dangerous situation. So around an airport, watch out for a light quartering tailwind as far as vortices are concerned. Now, let's assume you're landing behind a large aircraft. What should you do? Well, what you should do is fly above the landing aircraft's path of flight because his vortices are generated right here. They sink below the aircraft like so. And you want to land beyond the point where his nose wheel touches the ground. Now, lift is on his wings until his nose wheel touches the ground. So when you're landing behind a large aircraft, the pilot should avoid wake turbulence by staying above the large aircraft's final path and landing beyond the aircraft's touchdown point, like so. Now let's assume you're departing behind a heavy aircraft. Let's take a look at what you do here. As soon as that big aircraft's nose wheel leaves the ground, his vortices begin and they drift behind the aircraft and descend like so. So when you're departing behind a heavy aircraft, the pilot should avoid wake turbulence by maneuvering the aircraft above and upwind of the heavy aircraft like so. So if you're in a Cessna 150, you'd like to outclimb this 727, you'll play heck out climbing a 727, so you want to avoid his path of flight by turning away.